College, NECN TV. I am Dr. K.S.Sagar Reddy, Professor, ECE Department, Narayana Engineering College, Nellore. Today I would like to give the topics on electronic measurements and instrumentation. Electronic measurements and instrumentation is the two measurements and instrumentation. Measurement of any quantity plays role science in the and other branches of engineering, mechanical and all branches. Then the measuring instruments. What is instrument? What is the measuring instrument? It is the device for determining the value or magnitude of quantity or variable. This is measuring instrument. And the electronic instrument is the principles. It is based on electrical and electronic principles for measurement. Next, measurand. A quantity intended to be measured, physical quantity or property which is measured. Physical quantities can be converted into electrical or electronic signals using transducers. So the part transducer is used to measure to convert the physical quantities into electrical signals. So the purpose of transducer is converts physical quantities into electronic quantities, electrical or electronic quantities. Then this electrical and electronic signals can be amplified, filtered, multiplexed, sampled, and measured. So amplification is important, filter is important, multiplexing is important, sampling and measuring is also important. So the measure this it can be is a long distances. Measured quantities can be sent. We have to send to long distance using cables and radio links with the loss of information. So our aim is to communicate with the distortionless transmission is very important in communication. So in electronic measurements makes possible to build the analog and digital signals, higher sensitivity, low power consumption, and a high degree of reliability. So this is in optimization sense we have to consider low power and reliability. So reliability should be more. Power consumption is low. That is the main. These are the points will come under optimization. So in optimization sense, will take low power consumption and reliability, high degree of reliability. So that is the main important in our transmission. Next, we go to the measuring system. So how many measuring systems consist of? What are the our aim is the numerical values to provide the numerical values proportional to the quantity of variables being measured. Here we are taking elements, primary sensing elements, variable conversion elements, variable manipulation elements, data transmission elements, data presentation element, data storage, and playback element. So these are the main our fundamental elements of a measuring system. So primary sensing element. So this block diagram shows the elements. What are the types of how many types? Primary sensing element and variable conversion elements, variable manipulation elements, data transmission element, and data precision elements. So next, primary sensing element. The measurement first comes into the contact with the primary sensing element. If the conversion takes place. Here, primary the conversion means whenever we are using the equipment we are using in electronic measurements, transducer is the good element. It's a transducer converts the quantities, measured quantities, analog quantities into usable electrical output. Maybe a distances and means distances length, meters, centimeters, or any bench movements. We are using all this jigboarding side. We are using the x-axis, y-axis, and z-axis. These quantities, the transducer will convert into analog quantities into digital quantities. So these measure are some signals. It may be voltage, current, or say it is using in a in the machinery side, the CNC machines, computer numerically controlled machines, the bench movements from x-axis, y-axis, z-axis, all the axes will this transducer will convert into analog into voltages or electrical signals. So this mechanical, electrical, optical to any related form. The transduction may be from mechanical, electrical, optical to any related form. Then where next one second block diagram, second one is variable conversion element. So output of the primary sensing element in the electrical form suitable for control, recording, and display. The instrument to perform the desired function, it may be necessary to convert the output to some other suitable form for preserving the original information. So the function is performed by variable conversion elements. A system may require one or more variables conversion suitable to it. So next, data conditioning. Data conditioning means here the conversion elements and the variable manipulation elements are collectively called as a data conditioning or signal conditioning. So data conditioning and signal conditioning. Here, the transmission of data from one place to another place done by the data transmission elements. In case spacecrafts control signals sent from the control stations by using radio signals. So the stage that follows the signal conditioning elements and data transmission elements collectively is called the intermediate stage. And data presentation element. So the display readout device which display the required information about the measurement forms the data presentation element. Here the information of the measurement has to be conveyed for monitoring control monitoring purpose and control purpose. So and in case of data to be monitored, visual display devices are needed like ammeters, voltmeters, and so on are used. So, in case of data to be recorded, recorders, magnetic tapes, disks, and storage type, CRT, printers, and also and so on are used. Here, the performance characteristics. Here, there are two types of performance characteristics. One is static characteristics, and other one is dynamic characteristics. So instrument performance is the measuring instruments which are helpful to know the performance of an instrument and it help in measuring any quantity or parameters. Static characteristics. Here static characteristics, there are two types of performance characteristics. One is static characteristics and second one is dynamic characteristics. This is static characteristics. The first one is the static characteristics means it the parameters, the quantities or parameters do not vary with respect to time. That is called static characteristics. So sometimes these quantities or parameters may vary slowly with respect to time. Those static characteristics are accuracy, precision, sensitivity, resolution, static error, linearity, threshold, hysteresis. These are the These are the items in static characteristics. In accuracy is the closeness with which an instrument reading approaches the true value of the variable being measured. The algebraic difference between the indicated value of an instrument and the true value is known as accuracy. So the difference between indicated value of the instrument and the true value of the instrument. So the temperature measurement, it should give the perfect temperature. So at the known, it is the room temperature 26 degrees centigrade we are measuring with the, so we have to go to very near to 26 degrees of temperature, very closeness values. So this is known as accuracy. So mathematically this is a what is the difference indicated value of the instrument and true value of the instrument. To this indicated value minus true value, it will give the accuracy. So that is called formula wise. You can say accuracy is equal to AI minus AT. That is AI means indicated value minus the difference. That is AT means true value. The difference will give the accuracy. So the term accuracy signifies how much the indicated value of an instrument is close in the true value. So that is whatever the value we are measuring, always we know the exact values. It should reach, it should go to very closer to the true value. So in an instrument, that second one is precision. Precision is the instrument indicates the same value repeatedly when it is used to measure the same quantity under same circumstances for any number of times. Then we can say that the instrument has high precision. Here we can say that the value we are measuring, I am getting always temperatures. We are giving 26 degrees. Second time I measured, that is also 26.1. First time 26.1. Second time 26.1. Third time 26.1. So any number of times I am measuring, but I am getting the same value. So for any number of times, then we can say that the instrument has high precision. So measure of reproducibility of a measurement. So it should give the precision, should give the same value at any number of times we are measuring, but we are getting the same value. That is called a precision. So that is the values should be precise. Then sensitivity. Sensitivity means the ratio of change in the output of an instrument for a given change in the input that is to be measured is called sensitivity. Mathematically, sensitivity is equal to output by input. Means the change in the output to change in the input. That is called sensitivity. So you can give the formula mathematically, that is out delta A out by delta A in. That is sensitivity. Second, next resolution. Resolution means if the non-zero input quantity is slowly varying, but the output reading will not change until some minimum change in the input takes place. So that minimum change causes the change in the output is called a resolution. So here it is referred as discrimination of the instrument. Here the non-zero input quantity is slowly varying. So I am giving input but no change in output. So when the change in the input when so the minimum change in the input takes place, the minimum change in the causes the change in the output. That is called a resolution. So it is also referred to as resolution, the discrimination of a instrument. Next, error. The difference between true value or expected value of the difference between true value and measured value of the quantity is called error. So here E small e, the formula E is equal to yn minus xn. E means the absolute error, yn means expected value, xn means measured value. Then the difference is error. So absolute error of plus or minus 1 volt is negligible. When voltage being measured is of 1000 volts, but it becomes significant when it is it's a 5 volts. So the relative or percentage error specified instead of absolute absolute error. In the formula, this relative error can be expressed as absolute error by expected value. So absolute error by expected value. So error is mainly the difference between the difference between true value and to minus it will give expected value minus absolute measured value. I am measuring with a value that the difference will give the error will give the difference between this yn minus xn, that is the expected value minus measured value. Then percentage of error is equal to yn minus section by yn into 100. That is the formula for percentage of how much percentage of error in the measured values. Then next, static error types. There are there are okay, static errors. Thank
That is
you.
for today. And thank you.
Thank you. Today closing my lecture. Thank you.